So this problem relates to homework 2, problem 13. Now, this problem involves a new concept called centripetal acceleration. And so just to quickly explain what that is, since I think a lot of people are going to have a little bit of a lacking understanding, is when you have an object moving in a circle, its velocity at any given point is just tangent to the circle, and its acceleration at any given point is always pointing to the dead center. Acceleration points to the center. And we know that acceleration sub c, which means centripetal acceleration, is equal to v squared over r being the radius of the circle, and v being that tangential velocity. And so in this problem, it says that it takes her 5 seconds to get around the circle when she travels her slowest possible speed. And this means that the motorcycle is just barely touching the ring when she is upside down at the top. She is in free fall at that point. We know when we are in free fall, the only force acting on us is gravity. So at that very top point, at the top of the motion right here, a sub c, centripetal acceleration, well, that's just gravity. Gravity is the only thing accelerating her down. And it says that she makes it around without falling down, but what if she made a mistake and fell off the top? How high up is she? Would someone be hurt falling from this height? So what we have to do is figure out how high this circle is. What is that total top height? And we have to see, is that too high for somebody, if it was like 20 meters, yeah, she's going to fall, she's going to be seriously injured. But if it's only 1 or 2 meters, maybe she won't die, right? She won't be critically hurt. So now that we know our g, well, let's think about this problem. We know it takes her 5 seconds to travel around the circle. Well, if we think about velocity as distance over time, well, what distance is she traveling? She's traveling a full circle. That's the circumference. And if you remember the equation for circumference, it is 2 pi r. And that takes her 5 seconds, so you can put it over 5. So we can express her velocity just from knowing that the length of this circle in terms of r. And we can divide that by the time it took her, which is 5 seconds. And now we can take this velocity, we can take this centripetal acceleration, and we can plug that all into our centripetal acceleration equation. Where we find that g is equal to 2 pi r over 5. And that is all squared. That's divided by r. And then we kind of want to get that square out of there. So let's move over here to the left. All right, we're just doing some algebra to this. All right, it's going to be 2 squared times pi squared times r squared divided by 5 squared divided by r. So we can go ahead and do 2 squared is 4. Pi squared, we're just going to leave as pi squared. We have r squared, and we have divided by 5, and that is all over r. So how do we handle two fractions? This is one of the confusing things about this problem, and the algebra in this problem, is when you have two fractions, you can take the bottom divided fraction, right? Fraction in the bottom. And rather than dividing by it, you can actually rewrite it as multiplying by its reciprocal. And so the fraction in the bottom is just r over 1. But we can actually multiply instead by 1 over r. And we see that this r cancels out with 1r in the numerator. And so we have 4 pi squared, and just r to the power of 1 over 5. And we made a mistake. We forgot to put that 5 squared. That's going to be a 25. And so we find that, well, g is 9.8. We have 4 pi squared over 25 times r. Now, why did we use positive 9.8? Well, in this problem, the centripetal acceleration normally is not given a negative sign. It's usually always considered positive. Centripetal acceleration changes as you go around the circle, right? At one point it's pointing down, at another point it's pointing left, then right, then up, then diagonally. And so rather than trying to constantly convey what direction it points, we will normally just use it as the magnitude, right? So we're just talking about the magnitude of a sub c. And we can also tell that, what if we put a negative there? Well, if we put a negative there, we're going to end up finding r to be a negative number, right? All it is just going to be the flip sign. But we don't want r to be a negative number, right? We don't want a distance or a time that's negative. That just doesn't make sense. And so we know positive 9.8, it's going to give us that answer that we're expecting. The last thing to do is just some algebra to solve for what r is, right? So we're going to have 9.8. We're going to multiply both sides by 25 and divide both sides by 4 pi squared. And so this is going to give us our r value. We find r to be 6.2 meters. And so we know that as she goes around the loop, this is distance r, well, she's going to be actually diameter up, right? Diameter is 2r. She's going to be that full diameter up off the ground. So we have to actually multiply that number by 2. And so we find that she is 12.4 meters in the air. So this is actually kind of pushing the limit of how far you can maybe fall. And as a stunt person, you know how to fall. But this is kind of pushing the limit of maybe she's going to seriously injure herself if she lands on the hard loop.